Hi, good day. I'm Paul from Solis, and today I'm going to be speaking about our new S6 single-phase hybrid Pro inverter. On the left-hand side, we've got a completely unset up one. I'm going to go through each of the ports on the inverter so we can see how they work and what they do. And then on the right-hand side, we've got a completely set up inverter. Here on the right-hand side of the face of the inverter, we've got 4 indicators. One indicator showing a battery icon showing you the state of charge of the batteries. Then below that, we've got a status LED. When it's in good operation and it's operating correctly, it should be blue like it is now. If it was in a fault status, it would go orange. And if it was in a synchronization state, it would be blinking. It's mainly useful for those customers that just walking past their inverter, they can see the current status of their machine if everything is good. Then below that, we've got a Wi-Fi icon. So this inverter does connect to Solis Cloud and give us online monitoring from outside our house using this data logger. This data logger is in the box with the inverter, so that is fantastic. And then below that, we've got a Bluetooth icon. So as I said, there's no display on this inverter, so we don't set up this inverter using a display. We use this very elegant app, Solis Cloud, to set up this inverter, also be able to monitor this inverter. You get real-time information. Every 5 seconds the data refreshes. You can change the settings, you can look at graphs, all on the Bluetooth app, which is really helpful for setting it up. Now we're going to continue on to the different ports and interfaces we've got on the inverter. Starting on the left-hand side, like all our products, we've got 2 pairs of MC4 connectors. This is for your solar inputs. You connect your solar into here, up to 600 volts on the single-phase inverter. We've got our DC isolator on the right-hand side, just like a lot of our products, which in this installation, we've got a DC isolator, but having this DC isolator enables you to have installations without the requirements of having an external DC isolator. Then moving a little bit right, we've got our power connections for our battery. So we've got a red cable and a black cable, battery plus written on the PCB for the battery positive, battery negative written on the PCB for battery negative. This cable that we've got installed here is only a 25mm square cable. This is only good for 100 amps. This inverter can do 135 amps. So we won't have any problems on this installation because we've only got a 5 kilowatt-hour battery, and the battery will always limit the inverter to only 100 amps. So this cable is adequate for this system. But if you wanted to install more batteries on a system like this, on an inverter like this, you could still keep this cable and just set a setting on the inverter to limit the battery current to only 100 amps and still keep this cable nice and safe. Additionally, if you wanted to install it properly with a good amount of batteries, a nice big system like you should, you would need at least 35 square cable like these at the back here. This is good for 135 amps and would be required for a normal system. We don't supply battery cables in the box, so that's something you'll have to source yourself. Then moving on to the communication ports. So the other thing that works with batteries is it's not just power transfer. There needs to be communications between the inverter and the batteries, and that happens through CAN communications, and that is the first port on this inverter, the black RJ45 8-pin port over here. And that is a RJ45, so similar to the port that you would connect into your laptops for Ethernet communications. You can just go and insert it there. And the other end of this cable is plugged into your battery CAN port. Generally, so we are compatible with multiple different battery manufacturers. Most of them, it is a straight 8-pin to 8-pin cable for CAN communications. So you can get this cable, you can purchase this cable from many stores. You can also make it up yourself. But if you are making it up yourself, you can still have the other pins connected, but the only pins that we're actually using inside this plug is pin 2, pin 4, and pin 5. Pin 2 is ground, pin 4 is CAN H, and pin 5 is CAN L. So once you've made up the cable and it's connected into the battery, you can connect it into the first port over here. And then, actually, I'll leave that off just so I can talk about the rest of the ports, and I'll plug that all in later. So moving on one to the right, we've got a meter port. So the default operation that you should be using on this inverter to give it grid information is using the CT. So inside the box with the inverter, you do get a CT like this, and that CT is extremely important for the inverter to know the grid power information. The inverter always needs to know what the grid power information is all the time for it to do its job. So in the box with this hybrid, the S6 Pro hybrid, you get a box that looks like this. And in the box, you get a Wi-Fi/GPRS stick, which we are trying to encourage as much as possible that these inverters get online, and so you can look at it remotely, you can troubleshoot it remotely, and then we can do firmware updates remotely and do remote control remotely. Enough remotely. So that's that. Then you get that CT, which I've just spoken about, in the box with the single phase hybrid. It's a 100 amp on the primary, so it fits around a 100 amp primary cable. The mains cable is 100 amps, which is sufficient for most residential installations. The secondary is 50 milliamps, so 2000 to 1 would be the CT ratio for that. Then you get a battery temperature sensor. So on the one end is an RJ45, which fits into one of those ports there, and the other end is a lug which fits onto one of the lead acid batteries in your system. It's only used for lead acid batteries, so yeah, not lithium. So you would leave that in the box for lithium systems. Then you've got a paralleling cable. So these inverters can be paralleled. You can use 2 of these inverters to, for example, make a 12 kilowatt system. This is a 6 kilowatt inverter. You could put 2 of them together to make a 12 kilowatt system. You could put 6 of them, up to 6 of them in parallel to make a 36 kilowatt system. Now, just talking about paralleling in short, because I'm going to do a separate video focused on paralleling and setting up paralleling. But what's very important to note about paralleling is that there's broadly 2 different types of paralleling. The first one is self-use paralleling, which is grid-connected loads will be able to be supplied from the batteries using the paralleling function. So you'll be able to do self-use with a much bigger charging and discharging capacity, and then backup paralleling, which means that you can host your off-grid systems. Because these inverters can create their own grids, you can create much larger off-grid systems, like a 36 kilowatt single phase off-grid system using 6 of these inverters. So that's what that cable's for. Then you get MC4 plugs for your string side cables. You get some screws, and you get RJ45s, and that's for making up your cables for these connections here. And then what is also in the box, which is extremely important, is your mounting bracket. So the inverter sits on this bracket. The arrow points upwards when you put it onto the wall. So you would mount it on the wall like that. 4 screws in, spirit level first, then the screws in, and the inverter sits on these brackets over here. Carrying on with the ports, so we've got a meter port. So I've spoken about the CT, so that's the default setup that you would be going through, but the limitations with regards to CT is the maximum distance that this inverter can be from your grid connection is 10 meters. And a lot of installations might have it that it's 15, 20 meters, maybe even 50 meters. So in those cases, you will need to order from Solis an additional meter, a Eastron single phase meter, for example, and that is what it looks like. Over here, you would get this from Solis. You would set this up at your grid connection, and the CTs sit in here, and those CTs maximum distance is 10 meters, but that's fine because this is installed right at the grid connection, and then the long cable that you would have between the inverter and the meter can be up to 250 meters. And that's what you would do for those installations where the grid connection is far away from the inverter. That meter communication cable comes in to the into that meter port over there. Then you've got your two paralleling ports. You've got PA and PB. That's for setting up paralleling, and as I said, I will have a special video just for installing these inverters in parallel. Moving on to the bottom row, we've got DRM, which is grid requirements for the UK and some other markets. So that's what that port is for. And then lastly, we've got the RS485, which is just RS485 communications to the inverter for troubleshooting or whatever you desire there. Then moving on to the gray pin connectors, inserts. They're push-in terminal block that you can push the cable in and push to disconnect. Very nice and easy to use. The first two pins is HM, stands for hot mains, and that's where you plug the CT in. So for default installations, I said that that CT that you're using, the one that you got in the box, you put white into pin 1 and black into pin 2. Then you've got gen starts and gen stop pins. If you wanted to use a fuel generator with this inverter for those winter months where you're not getting enough solar energy, you would program the inverter to automatically start that generator when it's detecting a low state of charge, for example, and that's where you would connect those pins in. So it would electrically start that fuel generator for you. Then moving on to the AC power connectors, we've got the generator port, so that's where you would plug in that fuel generator into the generator port. We've got live, neutral, and PE, the earth connector. Then we've got here the middle port here, nice and loose, the backup connector. We've got live, neutral, and backup, and PE for the backup. And that's for the backup connection. So that's for your critical loads. So generally with these installations, if you're using backup, you would split your consumer board, your distribution board, into critical loads and non-critical loads. Essentially loads that you don't mind turning off when the grid goes down, and loads that you want always on no matter what. Light bulbs, your lighting in your house, your computers, your internet, your TVs, even some residential fridges would be perfectly okay on this, especially considering this is a 6 kilowatt inverter. I would find that the majority of your sockets in your house and fridges and everything would be on your house, maybe just excluding your heating. And then you would put the distribution circuit on that cable there. Then just one to the right of that, you've got your grid terminal block. Again, live, neutral, and PE. You can have your non-critical loads on there. For example, your water heater, you would put on that circuit there. And obviously the grid connection is also connecting in over here. So this inverter doesn't create a voltage at this point. It only takes a voltage at this point. It can send power out at that point. It just doesn't create a voltage at that point. It looks for a voltage at that point, and the inverter can create a voltage on the backup port. So when there is no grid, the inverter creates a voltage at this point and it sends 230 volts, 220 volts. It's settable on these cables here. And then conversely, it wouldn't create it here. So when the grid is on, the inverter closes some switches and puts that voltage, the grid voltage, onto the backup port. And then when the grid is not there, it detects that the grid is not there. It opens up a switch and it leaves the backup switches closed, and it starts generating a voltage on the backup, powering up those loads. And all of that happens extremely quickly, 20 milliseconds, so that's hugely fast. So we've explained each of the ports and how they work. Now I'm going to go ahead and do the install. So we're going to start off with the solar strings, the solar inputs. Here we've got a single string coming off the roof. It's always a good idea to test it just before we plug it in and start installing with it. So I'm just going to set my multimeter to measuring voltage. My multimeter starts on AC, so we're measuring DC here. So I'm just going to click select to move to measuring DC, and it starts off with millivolts. So I'm just going to press range a few times to make it measure in the range. It's around, my string is around 250 volts. So yeah, that's the range that I'm selected. Here you want to stick your red probe into the male MC4 plug, and you want to stick your black probe into the female, and you should be getting a result. There you go, I'm getting 226 negative. That is just a DC symbol, it's not a negative sign. If I did have to reverse it up, it would show a negative voltage. There we go, there's a negative sign at the bottom. So that's cool. Another thing that will tell me if my polarity is incorrect, because there's a power supply on the inverter, when you connect it in and turn on this isolator, it should power up the inverter. If it doesn't, then you could have a polarity issue, or your voltage collapses because of shading or something like that. A very good additional test to do is a PV isolation test. So what I will do there is measure your open circuit voltage. That's always what you start off with, and then leave your black probe connected into the female plug, and then connect your red probe onto AC earth. I've got my AC earth over here, so you can see there it starts off at a reasonably high voltage because it's discharging the parasitic capacitances on the string, but it does fall down quite quickly. So I usually say about 10 seconds is plenty time to wait. After 10 seconds, if you're seeing a voltage of less than 30 volts, it tells you that it should be a good string and there's no connections to earth on the positive rail here, because I've got my negative probe in the negative. It's telling me that there's no connections to earth on my positive. So now if I move my black probe from PV negative to PV positive and put my red probe on earth, it again went to 60 odd volts, then it dropped very quickly and it dropped less than 30. As soon as I see less than 30 volts, I'm pretty happy that there's no connections to earth. So I'm very happy with my string. I'm going to remove my multimeter here, place it to one side, and insert and connect my MC4s into the inverter. Making sure that your isolator is in the off position. You don't want current to flow as you're connecting it, so make sure your isolator is in the off position. I've got an isolator here, so what would be safer is to even turn this off, but a lot of installations are allowed to go in without this external isolator, and in that case you would have voltage live and present on the string as you're connecting it. So there's two pairs of inputs, should I say, at the bottom of this inverter, negative and positive for MPPT 1 and negative and positive for MPPT 2, but we've only got one string here. If you've got the second string, you would go into that port over there. Now, a good test, what I spoke about earlier, is just turning on the inverter's rotary switch, and you should see power up on the inverter, and that tells you correct polarity and there's actually power on my string. But there is circumstances, as I said, that even if you're getting voltage and you got correct polarity, even 300 volts, 400 volts, it might not start up the inverter, and that's nothing wrong with the inverter. That just means you got shading or poor performance on your solar inputs, say for example in the evenings or night. Cool. Next one we're going to do, so I'm just going to shut that off again because I'm very happy that that is correctly installed and that's all fine. Turning this off should shut down the inverter. There, it's done. And the next thing I want to install is the battery power connections. So there's two interfaces between a inverter and a battery, and the first one is power and the second one is CAN communications. So I'm just going to test the power ones here. So I'm going to measure the voltages here, and the battery is currently off. I'm going to need to bring my multimeter back into the position so we can all see it, not just myself. There we go, and we're still measuring DC here, and I would say the range of units is fine. We're looking for a voltage of about 48 volts, 49 volts, up to 50, 55 volts, depending on what battery you've got on your system. Generally, the battery manufacturers send you a battery that is reasonably close or at least 50% charged, so there should be a good amount of voltage coming from it. So we've got a positive and negative power lead here, and if this battery was on and you have to touch positive to negative, it would be a big spark and very unhappy for everybody. So I would always recommend putting it like when you're doing a test like this, put the lugs at a offset to each other, so that there's no chance, even if I trip, that the two lugs will touch each other. You desperately do not want them to touch each other. So I'm just going to put my red probe into here and my black probe into there. I'm getting 0 volts, and that makes sense because my battery is off. So I'm just going to turn on my battery, and you would read the user manual for your batteries to work out on how to turn on your battery, which I'm not going to highlight in this video. And there we go. So as the battery is turned on, I'm getting 53.8 volts, 54 volts, 54.1 volts between red and black, and that's good. Now definitely 100% turn off the batteries before you start connecting it into the inverter. If you at any stage touch those two contacts together, the protection inside the batteries is supposed to be good enough to protect against it, but I wouldn't like to see that happen. So yeah, I would always recommend make sure that it's off before you start connecting it into the inverter. I'm happy that it's fallen far enough, so I'm just going to again remove the multimeter. Let's just insert them into the port. So the glands right at the back is designed for the battery connectors. So on the PCB, battery plus is for my red battery plus connection to my battery. I would line it up, or semi-line it up at least, and then I would start tightening just semi-tightening the gland. First screw that one in. So I want a star screwdriver. So you're looking for those flathead screws that are got a much bigger surface area to conduct the current, so you definitely want to use the correct screws for these terminals. You don't want to put the baby screws into here. It won't let the current flow correctly. It won't actually screw in properly at all. So yeah, you don't want to do that. You want the battery connections desperately to be tight. You need them to be tight. If they're loose or anything like that, if they move around when you do a little wiggle, it will cause melting of those connectors, melting of the cables, melting of a lot of things, and a very unhappy customer. And there we go. And there we go, tighten again, very tight, needs to be super tight. Let's just double check my positive. There we go. One more time on the negative, good. So that's nice and strong, that's nice and strong. Very happy with that, and we will move on next through to the battery communications between the battery and the inverter. So for that, we're going to need the cable, the CAN cable. So it looks like that. It's a standard Cat5e cable. It's got an RJ45 at the end. I'm going to go through into the port here. You've got multiple options of ports that you can select from. But we've just chosen this port, whichever suits your layout the best. The reason why we chose that is because it lines up with our trunking the best. So we're going through with that port, and we would insert this cable into the first BMS RJ45 that I've spoken about already. And the other end of this cable is going into the CAN port into the batteries. And that's the batteries setup. If I turn that on with the solar, that's actually probably a good idea. So there's two power supplies on this inverter. There's the one from the PV, and the other one is from the battery. So if I power up the battery, the inverter should power up. We should get some LEDs and no CAN failure messages, but I'm not going to look at that at the moment because we're going to look at the app a little bit later. But that should start up the inverter. Let's just give it a moment. There we go. We're getting our indicators. There's power. It started up the inverter. And just like before, I'm just going to turn that off so we don't have power. Okay, so moving on to the next section, we're going to do a very important part. I always call this the most important part on the setup of these hybrids, also our previous hybrids, but it's setting up the inverter so that it knows about what current or what power is going through the grid connection. For a lot of its jobs, for example, its self-use function, it needs to know how much power is being imported or exported so it can do its job of either charging or discharging, and also how much. So it needs to be accurate and it needs to be correct for it to do its job correctly. In the box with the hybrid, you're getting the CT clamp. It's got a meter cable with it, so a meter black and white CT cable with it. And this is going to be used for most of your installations, and you would connect this up into the inverter. As I said already, pin 1 is white and pin 2 is black, and the CT needs to go around the live cable or the hot mains cable of your whole system. So not the load circuit, not the inverter circuit, but the mains grid connection live. And in a lot of installations, this cable might be more than 10 meters away from the inverter, and this is where you need to move to the meter solution. So for this solution, the limit of the mains distance between the mains and the inverter is 10 meters, and that's when you would use this if it's less than that, and you probably need to extend this. A meter is not very long. I am in talks about how we're going to extend this out of the box, but just to show us how we would possibly extend it. So I've got this cable here. It's 0.5 millimeters square per core. There's a red core and a black core. It's 2 cores, so we only need 2 cores because we've got 2 cores here. The colors I've got here is red and black. It's not important. You can do whatever colors you like as long as you follow that logic through on the cable. Here I would probably solder these two and put a heat shrink around it to make it look tidy, but you could use all sorts of methods of joining 2 cables together. Hopefully not just twisting it, because that would be very upsetting. But yeah, you would join, so in this example, I mean, my brain works in the way that I would join the 2 blacks together, and then I'll join white to red. My extension cable is 5 meters long. So if I go to the other end of this cable, so this section of the cable, the CT would go into my mains, which could be 7-8 meters away on the other side of the install, at the customer's house main consumer unit or main switch. So that would go at that section of the house, and then the other end of my cable, so this is 5 meter cable, I've got my red and black cable. And remember, I connected black onto black and white onto red. So the pinouts for here is I would go through the gland here, and I would connect my red into pin 1 and my black into pin 2, because white was pin 1 and black was pin 2. So I would go red pin 1 and black into pin 2. And then I would be happy with my install. I would go onto the settings onto Solis Cloud and select CT. However, a lot of these installations will have their grid connections more than 10 meters away, for example, 50 meters away, 60 meters away. And that's when you would need to use or contact Solis about shipping you a meter, an Eastron single-phase meter for your single-phase installations, and you would install it like this. So you would install this meter at the grid connection, and the CT cable at the bottom of the meter would be less than 10 meters. So it's very important that that analog signal is less than 10 meters. So this meter just needs to be installed within 10 meters of the grid connection. And then you've got a RS485 communication cable that sits between the meter and the inverter that can be up to 250 meters long. So essentially you could have up to 260 meters, 10 plus 250 meters between the grid connection and your inverter installation. Just going into on how to wire this e-stron meter, it does show us on the side of the meter on how to wire it. So you have live and neutral coming into the top where it gets voltage measurements as well as power supply from. And then you get the next rail, so these two pins here on the right hand side, pins 9 and 10 labeled there, is RS485B in the middle, pin 9, and A, pin 10, and then at the bottom is again where you put your CT. RS485 communications is not a very demanding on thickness cable. 0.3 millimeters squared is good enough for your RS485 cable. So you would have your cable running through to the inverter. I would always recommend making sure that your digital cables are running through trunking in a separate trunking, or like this trunking here, where it's 3-level trunking and you've got your digital communication cables here and your power cables in a different level of the trunking. And so you have it running through, coming up, and it will come into your inverter. So we, for the sake of this installation and the rest of this video, we are going to be thinking that we've done a meter installation. Even though my grid connection is within 5 meters, I am doing the meter install. So I'm going through the same port as the BMS CAN cable, and we can plug it through there, and then the second RJ45, black RJ45, on the bottom of the inverter is where you insert this cable, plug it into there, and that is done. Cool. Then I'm going to be moving on through to the next chapter, which will be setting up our AC power connections. We are going to, for the sake of this installation, select meter as our method of getting the grid information, the grid currents. So it's going to be communicating to the inverter over an RS485 cable, and it would be connected into this port here, like we've done here. If you wanted if your grid connection was 5 meters away, like this one is, but we've chosen the meter one, you can use the CT terminal block here, but I've already spoken about that. So this is all complete. We've done the battery, we've done the solar. The last thing to do is the AC power connections here. So the first terminal block is the fuel generator input. This video is not going to be about the fuel generator. We're just going to talk about the backup connections and the grid connections. So before we plug it into the inverter, we would want to measure the voltages on this cable. So at the moment it's safe because my isolator next close to my inverter is off, but essentially I'm going to measure the voltages between live and neutral and live and PE, and they should be in the region of 220 volts to 240 volts. So I'm just going to turn that on. Boom. It is on. I'm going to turn my multimeter back on into voltage AC. It's measuring AC voltage. Just going to, because it's quite a high voltage, I'm going to set the range to be quite high. Using my trusty brackets to hold my multimeter again, I'm going to put a probe onto live and a probe onto neutral, and I'm getting 238. Fabulous. Then I'm going to leave the black probe on live and I'll put the red probe on earth, and I'm getting 238. So I'm very happy that I'm getting voltages there. Very important, you need to isolate it before start working with it and putting it into the inverter. You don't want to touch that as it is now because it would be quite painful. So turn off this isolator. There's no capacitance in this cable, so you don't have to wait for it to discharge. It is already safe the moment you've turned that off, so that's pretty cool. And on the terminal block for your grid connection is on the right hand side, live, neutral and earth. So I'm just going to stick it into this gland hole here on the right, the most right hand one, and I'm going into that terminal block there. So I'm happy at that type of height. A little bit of play is sometimes good. So there we go, and that gets a little bit tightened, and then a flat driver will do the trick. So grabbing out of my back pocket, I'm searching for a flat driver, and I'm going to stick live into L, blue into neutral, and then earth into PE. And I'm just going to get onto this side of the inverter so you can see, and I'm just going to tighten it like this. It's very important that you put the ferrule or the cable on the closest side to you of the contact. So you want to tighten onto the bootlace, and you want to make sure that it's making good contact. It's extremely important, but you will be able to easily know when you've done it incorrectly. So if you had put the bootlaces on the bottom of the contact and you tightened it shut, these would just fall out immediately as you tighten it. So it's easy to work out when you've made a mistake or not. Going on to the backup connections, this is always safe because the inverter is not powered. So the inverter creates the voltage at this point, but there's no voltage being created at this time because the batteries are off and the solar is off. So everything is off, and you can see that by the indicators on the inverter. Again, you're going to go live on the left-hand side, neutral in the middle, and earth on the right. And I'm just going to jump onto the side again and tighten it up. And there we go. And it's getting tight. It's very important that these are tight, so any loose connections will cause pitting or melting of the contacts and cause a lot of damage. It does cause an avalanching effect, so yeah, do make sure that your connections on the AC terminal blocks is also tight. Everything needs to be tight. Last one here, we've got our PE for the backup. What's very important about wiring, and I'll probably do another video on just wiring of backups, but there's no connections between the lives from the grid and the backup here. So if I turn this on, without the inverter here, there won't be live here, and the neutrals aren't connected, and the PEs are not connected. Oh, well, actually the PEs are connected. They can be connected in some cases. So if you're relying on the grid's earth, even for your backup system, there would be connections between those two. And then if you've got your own earth spike, if it's a really good earth spike, you could also detect low resistances between those two. But neutral and live, definitely no connections between the backup and the grid. Okay, now that I've neatened up all the cables below and tightened this bottom chamber, it's extremely important to maintain the IP66 rating of the inverter to keep it waterproof, that you do this tightly. So these 4 screws here need to be tight so that it forms a seal around this chamber so water can't get in. And now we are ready to power it up to start setting it up on the app. So first things, so we've got 3 things here. We've got AC, which is always a good idea to go on first, and I'll explain to you in a moment. You can turn on solar. You can wait a long time to turn on solar. There's no rush or anything. And then we can turn on batteries, and then it powers up the inverter. The reason why I recommend turning on AC first is if you turn on the others first, no damage will be done, it will be perfect, everything will be fine, but an alarm code of no grid will be detected by the inverter if you take too long. If you're quick about it, you can skip that process, but an event log will be created and it will create a timestamp with no grid alarm, and that is just not good to see. So that's why I say AC first. So now that it's booted up, we can open up grab a phone. It can be an iPhone, an Android, a tablet, it doesn't matter, and you download the app Solis Cloud. Just before I do that, actually, the antenna that comes in the box, this nice long antenna, fits into the antenna port on the bottom of the inverter, and you just hand tighten it, and it boosts the Bluetooth strength. Oh, I'm struggling here to tighten it a bit. There we go, much better. That is not hard at all, my bad. So we don't have an LCD, so the way to set up this inverter and look at the inverter is through Bluetooth. On your smart device, you go to the App Store and search for Solis Cloud. You're looking for an icon that looks like that, and then you can download it. Now that we've downloaded the app, we've got it on our phone. We don't have to log in with into our accounts. We can just remain completely offline. It's very important that you can set up this inverter while offline. So you click at the bottom, more tools. If you click on that, it will take us to the options of setting it up locally or setting up a Wi-Fi connection. And then we want to go for a local operation, so we're connecting to the Bluetooth. Then we click connect to with Bluetooth. And then we've got a bunch of inverters in our lab at the moment. So if you've got multiple inverters, the serial number is the name of the Bluetooth network, and our inverter here is 005, so we're going to connect to that one. Okay, and at the moment, as soon as you press on that, on the inverter itself, it shows up the icon of Bluetooth, so you know that you are connected correctly to the correct inverter. Now there's two account types, there's end customer and installer, and end customers have obviously got, owners have got less abilities to change settings and less data, installers have got more. We are an installer, so let's click installer. And then the first time you connect to this inverter, it asks you to set a password, 6-character password, and it's very important that these passwords are safe. So I'm just going to select it to Solis 1. And just click the little eye icon to make sure it's correct. It's quite an effort to reset these passwords, so good idea to make sure that you know it. Set password. Then as you open up the app for the first time, it takes you up to a very useful wizard. So starting off on the wizard, we got inverter time. So if we just click follow phone time here, it will follow the phone's time and set it on the inverter. So that's quite nice. Click next. Then battery model. So we've got this inverter set up to a pure drive battery. So we're going to select pure drive. Then click next. Meter type. So as I said during the installation, we went with the meter solution, but in the box, you get that CT solution, which you could easily select here. When you do CT selection, you asked for a CT ratio. The default CT ratio for our inverters is 2000:1. When you're selecting meter, you've got options on what meters to select. Here we've got single phase meter, 3-phase meter, Estron. We've got a single phase Estron here, and we've got it connected on the grid. I would always highly recommend, almost insist that you put it on the grid connection and not on the load connection. So that's good settings. We can click save, and then we click next. And then we got grid codes here. So depending on the market that you've got, you select your grid code. We've got quite a few inverters selected. We try to ship out with the correct grid standard selected. So this is G99. We will click next, and then the work mode. For normal circumstances, it would be self-use. So that is when it's looking to optimize the energy inside the property and keep the energy local. And as soon as the inverter sees export, it charges. As soon as it sees that you're buying electricity, it discharges the batteries to stop those charging. So that's the default mode. The other common mode that we often see is time charging. So if we go into self-use, we can set time charging. For example, if you got a cheaper tariff between midnight and 4 o'clock in the morning, you would set a charge time. So you would set the start time to midnight to 00 and the end time to 4 o'clock in the morning. And how this logic works is anything undefined, it will revert back to self-use. And that's exactly what we want. When it's in that cheaper tariff period, we wanted to charge from the grid as fast as, at the charge current we define. And then outside the periods, we want to, if we are importing and buying electricity, it must charge, it must
discharge the batteries to stop that import. And then conversely, if we're selling the electricity again, we should have it that it will charge the batteries when it sees export. So that's cool. So to do that, you must just make sure that all the other periods are undefined and you've got the start time for discharging equal to the end time for discharging. So that second discharge time slot, it's starting at 8 a.m. and ending at 8 a.m. So that's fabulous. So cool. You just need to make sure. So if you have that time of use switch at the top there disabled, it will never use the settings below. So as soon as you hit time of use switch, it's now using those settings below and it will charge accordingly. Those limits. So it's healthy for your batteries to charge them as slow as possible. So calculate the total kilowatt hour capacity of your batteries, and you've got the total time to charge it, divided by that to calculate the power at which you want to charge it. And then it's a 50 volt nominal battery, so you can calculate the current after that. So we've selected 50 amps, and that's fine. Allow charging from grid should always be enabled for this application, as well as force charging to keep your batteries alive when they are critically low. So that's a good setting to always leave enabled. Then battery reserve at the bottom is useful for the cases when you're trying to use UPS circuits or backup circuits in conjunction or as well as self-use. So if you wanted to use 20% of your battery for self-use and the rest is must be kept for a backup scenario, you would set that to 80%. If you wanted to keep 40% for self-use and 60% for backup, you would set that to 60%. So we're going to set it to 60% because we don't mind. We've got a lot of space in our batteries, and we will, in the period of backup, we will survive with 60% battery. And then you also need to enable that, obviously. Okay, so we've done with the modes. There are other modes on the screen. Is feed-in priority, which is seldom used, and yeah, I'll do different videos for that, explaining that. And then off-grid mode is just makes the inverter in a completely off-grid mode, and it doesn't connect to the grid at all. Then you click next. And we are done with setting up the inverter. The inverter should be completely set up, and now I would highly recommend some troubleshooting and turning on kettle. I always call it a kettle test. Turn on the kettle, make sure that it discharges the inverter as you turn on the kettle, because that's what you would expect in self-use. When it sees that the import is coming from the grid, from that kettle, it should discharge the batteries to cancel out that import. However, obviously, if you've got a lot of solar coming in and you're exporting excess power, or you've got enough solar power coming in to supply that kettle, it will not do that. So just do things that will run the tests in your head and make sure it all makes sense. On the top right-hand screen of this screen, you can see the status of the inverter, and it says run. So everything seems okay. We've got our solar panels on this overview screen showing us our real-time solar power generation. Then our battery information, our battery SOC in the middle. Our energy values are spread across the screen as well. And then your consumption and usage on the system is also shown here. So yeah, that all looks good. And we are happy. If you wanted to see alarm messages, you can click on the alarm at the bottom and you can see the current alarm. We haven't got any alarms on here, but if we had to turn off the grid isolator, we would see it there, and that's good for troubleshooting. And then information is also extremely useful for troubleshooting. But we have set up this inverter and we are really happy. So thank you very much, and cheers.